Yo, 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 yo. Finals week is next week for AP Calc, so I'm gonna walk us through some practice problems. We have two pages here. I'm gonna do the first one today and the second page in another video. This FRQ will be linked in the comments, so if you want to follow along or do it yourself, you can do that. But enough yapping, let's go. So first, I'm just gonna write my name down and the date and the period. So the first question, we have a graph of the velocity of an object. Um, the first part says, when does the body reverse direction? And when something reverses direction, the velocity either goes from positive to negative or negative to positive. So from the graph, the velocity is positive when it's above, when it's above y equals 0. So this axis right here. And it's negative when it's below that axis. So we're just gonna color it in. And as we can see, it changes direction at 4 seconds and 8 seconds because it goes from positive to negative, then negative to positive. So we can write that down. Time equals 4 seconds. Time equals 8 seconds. Okay. Part B, when is the body moving at a constant speed? Let's erase all this. So, when an object is moving at a constant speed, the derivative of velocity or the acceleration is equal to 0. In other words, if we have a graph of the velocity, we want to find the place where the slope is equal to 0. And from the graph, we can see that it's between 6, 7. Sorry. So let's just write that down. And let's erase this. At what time intervals is the body slowing down? Is the next question. And it's slowing down when the velocity is positive and the acceleration is negative, or when the velocity is negative and the acceleration is positive. So let me write that down. Okay. So on a graph, we want to find our critical points. And what I mean by that is when our acceleration is positive, when our acceleration is negative, when our velocity is positive, and when our when our velocity is negative. We want to find when it switches from positive to negative, and the same thing for velocity. So let's do that really quick. Right here, at time equals 2 seconds, our acceleration goes from positive to negative. So that's our first special point. Our second special point is that time equals 4 seconds because that's when our velocity goes from positive to negative. Our third special point is that c equals 7 seconds. And we're gonna skip this part right here from 6 to 7 seconds because it's we're just gonna skip it. All right, leave me alone. And finally, our last special point is that time equals 8 seconds because that's when our velocity goes from negative to positive. Let me erase this just to make some space. Actually, no, let's do it down here. So let's draw a table, wow. And let's write our velocity and our acceleration. Well, let's do the velocity side first. So from 0 to 2 seconds, the velocity is positive. So let's just write it in green from 0 to 2 seconds. Then from 2 seconds to 4 seconds, our velocity is still positive. So, oops, 2 to 4. Then from 4 to 7 seconds, our velocity is negative. So let's write it in red from 4 to 7. From 7 to 8 seconds, our velocity is still negative. So let's write it here. And finally, from 8 to 9 seconds, our velocity is positive. So let's write it in green. 8 to 9. All right, now let's do our acceleration. So from 0 to 2 seconds, our acceleration, is positive because it has a positive slope. So 0 to 2. Then it goes to negative from 2 to 4. It's still negative from about 4 to 7. Or 4 to 6, actually. It has... Well, it doesn't matter. I'll just write a 6 here. From 7 to 8 seconds, the slope is positive. And it's still positive from 8 to 9. So now we're gonna erase the time intervals with the same color. So when they're both positive or when they're both negative. And that leaves us from time equals 2 to 4 seconds to time equals 7 to 8 seconds. And we're done with that. So let's erase everything. Okay, so on to the next part. Use L'Hopital's when possible. So first we're just gonna plug in 2 for this limit equation. So 2 minus 2, so 2 squared minus 7 times 2 plus 10. The top goes to 0. The bottom also goes to 0, so this limit approaches 0 over 0. So it's indeterminate. And we can use L'Hopital's. We can take the derivative of the top part, the numerator, which is 1, and we can take the derivative of the bottom, which is 2x minus 7. Plugging it into, we get 1 over negative 3, which is our answer. We can also factor it, so limit as x approaches 2 of x minus 2. You can factor it with x minus 2, x minus 5. Cancel the top, cancel the bottom. We get the limit as x approaches 2 of 1 over x minus 5. Oops. And 2 minus 5 is negative 3. So we get the same answer. Both way works. Whatever you find easier is what you can use. Alright, question 3. We have the limit as x approaches 0 of 3x squared over e to the x minus 1 minus x. So again, let's just plug it in. E to the x minus 1 minus x. Plugging in 0, we get 0, 1 minus 1 minus 0. So again, we get 0 over 0. We can use L'Hopital's. So indeterminate. Oops. Taking the derivative of the top, we get 6x. Taking the derivative of the bottom, we get e to the x minus 1, which is 6 times 0. E to the 0 minus 1, which is equal to 0 over 0. So we get 0 over 0 again. So we can use L'Hopital's again. I'm not gonna rewrite it, so just gonna use the arrow. Alright. Taking the derivative of the top, we have 6. Taking the derivative of the bottom, we have e to the x. Plug in 0, we get 6 over e to the 0, or 6. And put a box around it. Put a box around it here too. Alright. On to question 4. We have the derivative of 3x minus 2 over 5x plus 1. So here we're going to use the quotient rule, and hopefully you remember that because that's Unit 2 stuff. So let's just quickly work through it. The derivative rule for quotients is f prime of x times g of x minus g prime of x times f of x, where the top part is f of x and the bottom part is g of x. And all of this over g of x squared. So the derivative of the numerator, that's just 3. G of x is 5x plus 1 minus the derivative of the bottom is just 5 times 3x minus 2. And that's over 5x plus 1 all squared. Let me just erase the top part to make space. Alright. Oops. So if we expand everything, we have 15x plus 3 minus 15x plus 10. The 15x's cancel out. I'm not gonna FOIL it. You can if you want, but we get 13 over 5x plus 1 squared. Let's just move everything over. Put a box around it. And that's our answer. Okay, if the length L of a rectangle is decreasing at a rate of 2 inches per minute while its width is increasing at a rate of 2 inches per minute, which of the following must be true about the area of the rectangle? Okay, so what do we know? We know that the length is decreasing at 2 inches per minute. So that's a rate for the length, dl over dt, which is -2. We also know that the width is increasing at a rate of 2 inches per minute. So our derivative for width, dw dt, is equal to 2. And we want to know what's true about the area of the rectangle. So the equation for area is A equals L times W, where A is our area, L is our length, and W is our width. Then we're gonna take the derivative of this. So dA dt is equal to, we're gonna use the product rule. So the derivative of L is 1 times W, and we need our dl dt because we're taking the derivative with respect to time. And we're gonna do the same thing with length, and we get dw dt. So now we're gonna plug in our rates. So we get -2w plus 2l, and that's equal to our dA dt. Now I'm gonna factor out a pair of 2, so we get 2. And then I'm gonna rearrange the equation so we get L minus W, and that's equal to our dA dt. So let's look through our answers. Our first option, A, the area is always increasing. Is that true? No, because if our width is larger than our length, then this becomes negative, and it would mean that dA dt would be decreasing. So A is wrong. A is always decreasing. Well, if L is bigger than W, then this would be positive, and dA dt would be increasing. So this is also wrong. Option C, area is increasing only when L is bigger than W, that's our answer, right? As I said before, if L is bigger than W, then it's increasing. So C is our answer. And that's all for today. We got through the first page. We'll do the second page in another video. Thanks for watching, thanks for following along, and see you next time.